In this question from JEST 2024, we are given 4 functions of internal energy. We have to identify which of the following is not a valid thermodynamic function of internal energy. So we make use of a property of fundamental relations. We know that fundamental relations are expressions of internal energy or entropy, and in the case of fundamental relations, total power of extensive variables is equal to 1. This is in the case of fundamental relations. We are also familiar with extensive variables. Extensive variables are those variables which depend on the amount of matter. For example, number of particles. If we increase the amount of material in the system, number of particles is going to increase, so n is extensive. If we increase the amount of matter in the system, volume is also going to increase. If we decrease the amount of matter, entropy is also going to decrease. So all of these depend on the amount of material in the system, and therefore they are all extensive. Now let's check if each of the options are valid by calculating their total power of extensive variables. So in the case of option D, we have C is constant, power of n is 2, and power of S and V together is -2. They are inside an root, so we have total power equal to 2 minus 1 by 2 into 2, which is equal to 1. So this is a valid thermodynamic function because total power of extensive variables is equal to 1. In the case of option C, we have B is constant, power of S is +2, power of V is also 2, power of N is -3, so total power is 1. This is also a valid thermodynamic function. In the case of option B, we have power of A V square by N equal to 2 minus 1 equal to 1, and inside the exponential we need power to be equal to 0. Power of V is 1 and power of N is 1, power of S is -2, so this is equal to 0. Exponential power inside the exponential power is 0. So this is also a valid thermodynamic function. In the case of A, U0 is constant and the power inside the exponential, it is not 0. So the total power of extensive variables is not equal to 1 in the case of option A. Therefore, option A is not a valid thermodynamic function of internal energy.